the shocking discovery of the Kuiper Belt. Picture this. 4 billion miles from where you're sitting right now, the temperature sits at -230 degrees Celsius. The same star that warms your skin every morning has been reduced to nothing more than a fierce pinpoint of light in a perfectly black sky. Not a disk, not a source of warmth, just a bright dot in an infinite void. And here's what should stop you cold. We're not talking about some alien solar system in a distant galaxy. We're talking about our solar system, the one you grew up learning about. Beyond the last recognizable planet, there exists a vast and largely ignored region that will completely reshape your mental image of the place we call home. If you've ever had that feeling that there's more to a familiar story than anyone bothered to tell you, buckle in, hit like, subscribe, and let's get into it. The picture you were given was wrong. Every classroom poster, every textbook diagram, every animated explainer you've ever seen about our solar system tells essentially the same story. 8 planets arranged in a neat row, spreading outward from the Sun from Mercury to Neptune. A few moons, Saturn's rings, maybe a nod to the asteroid belt. Then the image just ends, as though Neptune marked the outer boundary of everything. That image is not accurate, not even close. Starting at approximately 30 astronomical units from the Sun, 1 astronomical unit being the 93 million miles separating Earth from our star, there begins a colossal ring-shaped region of frozen debris called the Kuiper Belt. It stretches outward to at least 50 astronomical units, and its scattered objects push well beyond that, reaching 70, 80, even 100 astronomical units in some cases. To travel from Earth to the inner edge of the Kuiper Belt at ordinary highway speed, you would need to drive continuously for more than 5,000 years. To reach the outer edge, add another 2,000 on top of that. All of it in freezing darkness, all of it in a perfect vacuum, the Sun shrinking steadily behind you from a warm disk into a cold, distant star. Now consider what this means for how we understand the solar system's actual size. The entire stretch of familiar planetary territory, every world ever visited by a human mission, every moon ever photographed, every orbit ever mapped, spans about 30 astronomical units. The main body of the Kuiper Belt alone covers 20 more. That means a region most people have never heard of accounts for 2/3 as much space as the entire system you were taught about. Include the most distant scattered objects, and the Sun's icy outer domain reaches out to 100 astronomical units. Everything on that classroom poster, 8 planets, all their moons, every spacecraft's destination, fits inside the inner third of our solar system's true gravitational reach. This distortion didn't happen by accident. Classroom diagrams are forced to compress enormous distances onto a piece of paper. Planets end up shown at roughly equal intervals. The image stops at Neptune or Pluto, and the Kuiper Belt, when it appears at all, shows up as a faint dotted arc in the corner. If you drew the solar system with honest proportions, the 8 familiar planets would cluster tightly in the leftmost portion of the image, and the Kuiper Belt would extend outward for twice their combined span. The solar system wouldn't look like a tidy row of planets. It would look like a glowing central cluster surrounded by an enormous frozen halo. The mental model most people carry isn't just incomplete, it is structurally wrong. What fills that frozen hollow, the Kuiper Belt, is not empty. Astronomers have cataloged over 3,000 confirmed objects so far, and the estimated number of bodies larger than 1 kilometer runs into the hundreds of millions. Current models suggest more than 100,000 individual objects exceed 100 kilometers in diameter, roughly the size of a small American state. By sheer count, the Kuiper Belt holds more individual objects than the asteroid belt between Mars and Jupiter, while occupying a volume of space thousands of times larger. The total space enclosed by the Kuiper Belt is roughly 100,000 times greater than the entire sphere of space contained within Earth's orbit. The familiar annual orbit of our planet disappears inside the Kuiper Belt the way a thimble of water disappears inside a tanker truck. And yet, despite all those objects, the distances between individual bodies are so immense that if you stood on any one of them, you would see nothing nearby. No neighboring world, no bright companion in the sky, just an ocean of perfect black silence filled with stars in every direction, and the sun, still the brightest thing visible, but no more than a very bright star. The average separation between large Kuiper Belt objects is tens of millions of miles, roughly the gap between Earth and Mars at their closest approach. Every one of them drifts through its own private expanse of nothing. When New Horizons flew past the small Kuiper Belt object Arrokoth in 2019, engineers had to aim the probe with extraordinary precision years in advance just to pass within 3,500 kilometers of a target 36 kilometers long, embedded in a region where the nearest comparable object was roughly 50 million miles away. That is the reality the diagrams never show. The Kuiper Belt is not a crowded ring of jostling ice. It is overwhelmingly, profoundly empty. The search that took 5 years of nothing, the Kuiper Belt has been confirmed science for over 3 decades. But getting there required one of the most painstaking astronomical searches in history. In 1987, astronomers David Jewett and Jane Liu began scanning the outer solar system from telescopes on Mauna Kea in Hawaii, hunting for faint objects drifting slowly against the fixed background of stars. They were searching for points of light millions of times, dimmer than anything the naked eye could detect, shifting almost imperceptibly across the sky over hours and nights of comparison. A moving dot meant something was orbiting the sun far out in the dark. A stationary dot was just another star. Night after night, year after year, they scanned and compared. 5 years of searching produced 5 years of nothing. The outer solar system appeared to be exactly what conventional wisdom had always suggested: empty. Then on the night of August 30th, 1992, a faint object appeared in the data, drifting at exactly the rate expected for something orbiting at roughly 44 astronomical units from the Sun. Not an asteroid, not a comet, not any known class of object. It was designated 1992 QB1, and its discovery cracked open a door that could never be closed again. Within months, they found more objects. Other teams joined the search. Within a decade, hundreds of new outer solar system bodies had emerged from the data. The Kuiper Belt went from theoretical to undeniable. Frozen time capsules from the birth of the solar system. What makes the Kuiper Belt more than simply a large region is what its objects are made of. Unlike the rocky and metallic bodies of the inner asteroid belt, Kuiper Belt objects are composed primarily of frozen volatiles: water ice, methane ice, nitrogen ice, ammonia, carbon monoxide. These substances can only remain solid at the brutal temperatures found beyond Neptune, where surface readings hover around -230 degrees Celsius. At those extremes, methane, the gas that heats a kitchen stove, becomes a pale crystalline solid. Nitrogen, the gas that makes up most of the air you breathe, freezes into a translucent frost. When the solar system formed 4.5 billion years ago from a rotating disk of gas and dust, the region close to the sun was too warm for our ices to condense. Only rock and metal survived there, eventually building the terrestrial planets. Farther out, beyond what astronomers call the frost line, temperatures dropped low enough for ices to join rocky material in building solid bodies. The giant planets assembled in this colder zone. But beyond Neptune, the disk was too sparse for a full planet to form. The building blocks simply stayed as building blocks. Individual chunks of ice and rock, orbiting slowly, never gathering into anything larger. These are the Kuiper Belt objects, planetary construction debris, raw ingredients from a recipe that was never finished. And because the belt is so cold and so remote, those ingredients have been preserved in near original condition for 4.5 billion years. They are fossils of the protoplanetary disk, frozen time capsules recording the chemistry of a structure that no longer exists anywhere else in the solar system. The belt's current form, however, isn't simply where everything was left behind. It was violently sculpted. In the early solar system, the giant planets didn't occupy their current positions. Neptune in particular migrated dramatically outward, sweeping through the primordial outer disk like a hand sweeping marbles off a table. Vast numbers of objects were flung inward, many becoming the impactors responsible for the ancient craters that scar the Moon and inner planets. Others were ejected from the solar system entirely. Still others were captured into orbital resonances, gravitational rhythms with Neptune that stabilized their paths across billions of years. Pluto is the most famous example. It completes exactly 2 orbits for every 3 that Neptune completes, a gravitational lockstep protecting it from close encounters for the entire age of the solar system. Hundreds of other icy bodies share this same rhythm, collectively called plutinos. What this layered structure reveals is remarkable. Neptune didn't just sit next to the Kuiper Belt. Neptune built it. Every resonant population, every gap in the orbital distribution is a forensic clue pointing back to a period of violent reorganization more than 4 billion years ago. Estimates suggest the current belt contains only a few % of the mass that originally occupied the outer disk. The objects that remain are not just ancient, they are survivors. Worlds within the wilderness, the Kuiper Belt contains actual worlds, bodies with surfaces, geology, moons, and histories stretching back to the birth of the Sun. For decades, Pluto was treated as a lone outpost at the edge of the solar system, the 9th planet, the runt at the back of the line. Beyond it, nothing. That story was never true. Pluto is merely the most famous member of a vast community of frozen worlds, and not even the most massive. Eris, discovered in 2005, is slightly denser and more massive than Pluto, despite being nearly identical in diameter. It orbits on a wildly eccentric path, carrying it from 38 astronomical units at closest approach to nearly 98 at its farthest, deep into the scattered disk. Its surface is coated in bright methane and nitrogen frost, giving it one of the highest reflectivities of any body in the solar system. When its discoverer Mike Brown realized it was larger than Pluto, the community faced a choice: add a 10th planet or reconsider what planet actually meant. In 2006, Pluto was reclassified as a dwarf planet, not because it had changed, but because the solar system turned out to be far more crowded than anyone had admitted. Haumea is perhaps the strangest of the dwarf planets. It spins so rapidly, one full rotation in under 4 hours, that centrifugal force has stretched it into an elongated shape resembling a flattened rugby ball. This extreme rotation is thought to be the remnant of a massive ancient collision that also scattered a family of smaller icy fragments across similar orbits, the only known collisional family in the entire Kuiper Belt. In 2017, astronomers discovered that Haumea possesses a ring system, the first ever detected around any trans-Neptunian object. Quaoar, orbiting at about 43 astronomical units, surprised everyone in 2022 when astronomers detected a ring around it sitting well outside its Roche limit, the boundary inside which tidal forces should prevent ring material from coalescing into a moon. According to existing models, that material should have clumped together long ago. Instead, it remains a ring, stable and unexplained, defying the theoretical framework planetary scientists had applied to every ring system ever studied. In 2025, additional observations suggested Quaoar may also harbor a hidden moon, making it a more complex system than anyone had suspected. Pluto up close. A world that rewrote the rules of all the worlds in the Kuiper Belt, Pluto is the only one visited up close. And what New Horizons revealed when it arrived in July 2015 dismantled virtually every assumption scientists had carried about what a frozen outer solar system world should look like. The expectation was a battered, Cratered surface, geologically dead for billions of years, too small and too cold to drive anything resembling activity. The images showed something else entirely. The Western Hemisphere is dominated by a vast heart-shaped feature now officially named Tombaugh Regio, after Pluto's discoverer Clyde Tombaugh. Its left lobe contains a basin of nitrogen ice roughly 1,000 kilometers across and several kilometers deep, called Sputnik Planitia, one of the smoothest surfaces ever observed anywhere in the solar system. No visible impact craters in a region where cratering should be the dominant surface process across billions of years. A blank slate that size means only one thing: something is erasing them. Something is still active. That something is convection. The nitrogen ice filling the basin is not static. It churns. Warmer ice rises from below, spreads across the surface, cools, and sinks back down at the edges, creating slow rolling cells roughly 30 to 40 kilometers across. The process operates on timescales of roughly 500,000 years per cycle, slow by human standards, but geologically vigorous for a world receiving less than 1,000th the solar energy that reaches Earth. Along the basin's edges, mountain ranges of water ice rise abruptly to 3 to 4 kilometers, rigid enough at these temperatures to support steep slopes and structural peaks unchanged for billions of years. Long extensional faults stretch across Pluto's surface, fractures consistent with internal expansion. The leading explanation is that a subsurface ocean of liquid water has been slowly freezing over geological time. Water expands as it freezes. As that hidden ocean solidifies from the outside in, the expanding ice pushes outward, cracking the surface above it. Thermal models suggest a layer of liquid water, possibly mixed with ammonia as a natural antifreeze, could persist beneath the ice shell to the present day, kept from freezing by residual radioactive decay in Pluto's rocky core. If that ocean exists, Pluto joins Europa, Enceladus, Titan, and Ganymede as worlds where liquid water persists far from the warmth of the sun. And if it can happen on Pluto, a body barely larger than some moons, orbiting at 40 astronomical units, the implications for the wider Kuiper Belt population are enormous. Dozens of other outer solar system objects are comparable in size to Pluto. If even a fraction share similar internal structures, the cold outer reaches of our solar system may harbor far more liquid water environments than anyone had imagined. The snowman at the edge of everything. On the first day of January 2019, New Horizons flew past a small Kuiper Belt object called Arrokoth at a distance of about 3,500 kilometers. It was the most distant close-range flyby in the entire history of space exploration, conducted in a region so remote that the signal confirming the encounter took over 6 hours to reach Earth. What the cameras returned changed the way scientists think about how the solar system assembled its smallest bodies. Arrokoth is a contact binary. 2 roughly flattened lobes joined at a narrow neck, a shape that drew immediate comparisons to a snowman or 2 pancakes gently pressed together. The larger lobe spans about 22 kilometers across, the smaller about 14. Their surfaces are uniformly reddish, coated in complex organic molecules called tholins, a dark, tarry residue that forms when ultraviolet radiation and cosmic rays act on simple ices like methane and nitrogen over billions of years. The shape was the real revelation. Arrokoth did not form through a violent collision between 2 separate objects. The evidence pointed to something far more delicate. The 2 lobes came together at speeds slower than a person can comfortably jog, the result of 2 bodies forming close together, orbiting each other in a gradually tightening spiral and eventually making contact so gently that neither lobe was deformed or shattered. The resulting object preserved the shape of both original components almost perfectly, like 2 scoops of ice cream placed carefully together and then frozen solid for 4.5 billion years. This gentle assembly supported a theoretical model called the streaming instability hypothesis. The idea proposes that small solid particles in the early solar nebula, pebble-sized grains drifting through the gas disk, can concentrate into dense filaments through aerodynamic interactions. When these concentrations reach a critical density, they collapse gravitationally into bound objects, bypassing the slow grinding process of dust grains sticking together one at a time. The streaming instability naturally produces binary pairs which spiral together and merge. Exactly the history Arrokoth's shape had preserved. It was the first direct observational confirmation that this process occurred in the outer solar system, and the implications reach far beyond the Kuiper Belt. If gravitational collapse built the small bodies of the outer disk, the same mechanism may have shaped the initial building blocks of every planet. Arrokoth also revealed that the cold classical belt is genuinely, unusually calm. Its surface showed almost no small impact craters, an eerie smoothness at scales where most solar system bodies are pockmarked with tiny pits from billions of years of minor impacts. Objects there are separated by such vast distances and move at such low relative velocities that violent collisions are rare. Delicate structures like contact binaries can survive intact for the full age of the solar system. In February 2026, computer simulations published in the monthly notices of the Royal Astronomical Society showed that a spinning cloud of pebble-sized material can collapse, separate into two gravitationally bound lobes, and bring those lobes together without destroying either one, reproducing the full range of contact binary shapes observed across the belt. Between 10 and 30% of small Kuiper Belt objects display brightness patterns characteristic of elongated or two-lobed shapes. The frozen outer solar system is populated with snowman-shaped relics of gravitational collapse, each one a fossil of the planet-building process preserved in deep freeze. Ambassadors from the deep freeze, the Kuiper Belt does not simply sit passively at the edge of the solar system. It sends representatives inward. Short-period comets, the kind that return to the inner solar system on timescales of roughly 20 years or less, originate primarily from the Kuiper Belt. Objects near the belt's inner edge occasionally get nudged by Neptune's gravity onto orbits that cross Neptune's path. From there, gravitational encounters with the giant planets progressively pull each object's closest solar approach inward over millions of years until it eventually crosses into the inner solar system. What happens next is one of the most dramatic transformations in the solar system. For billions of years, the object drifted in the deep freeze of the outer reaches, its surface locked near -230 degrees. Nothing happened. Nothing changed. Then, slowly, its orbit tightens. Somewhere around Jupiter's distance from the Sun, the surface temperature begins rising enough for volatile ices to respond. Gas erupts through cracks and vents, carrying dust particles outward in jets. A coma forms, a diffuse cloud of gas and dust glowing in reflected sunlight. Then the tails develop, one made of ionized gas pointing directly away from the Sun, another made of dust curving along the orbital path. After 4.5 billion years of frozen stillness, the object is being dismantled by the very star that created it. When a comet blazes across the night sky, that is exactly what you are watching. Ancient Kuiper Belt ice sublimating in real time, releasing molecules that formed before the Earth existed. Comet Wild 2, sampled by NASA's Stardust mission, contained glycine, one of the simplest amino acids and a fundamental building block of proteins. The outer solar system has been quietly producing the raw chemistry of life for billions of years and periodically delivering it inward. During the period of heavy bombardment, roughly 4 billion years ago, when Neptune's migration was scattering icy bodies inward by the billions, a sustained rain of cometary material fell on the young Earth. Some scientists propose that a significant fraction of Earth's oceans arrived this way. The isotopic ratios of hydrogen in certain comets match those found in Earth's oceans closely enough to keep the hypothesis alive and actively debated. A world that shouldn't have an atmosphere, but does. The surface compositions of Kuiper Belt objects reflect an enormous chemical richness that has only recently come into focus. The largest objects, Pluto, Eris, Makemake, have surfaces dominated by frozen methane, nitrogen, and carbon monoxide. These volatile ices can sublimate and redeposit over seasonal cycles, creating active surface processes even at extreme distances. Smaller objects tend towards surfaces of water ice mixed with dark reddish tholins. The color distribution across the belt is not random. Cold classical objects tend to be redder, while hot classical and scattered disk objects trend toward grayer tones. A divide that tracks dynamical history. In the Kuiper Belt, color is a tracer of origin. Then, in May 2026, a team of Japanese astronomers announced something that stopped the planetary science community in its tracks. During a stellar occultation observed from multiple sites in Japan in early 2024, starlight dimmed gradually as a Kuiper Belt object designated 612533, a plutino roughly 500 kilometers in diameter, passed in front of a background star. A gradual dimming rather than a sharp cutoff meant only one thing: a gaseous envelope surrounding the object. A thin atmosphere where no atmosphere should exist. The detection was startling. Objects of this size and distance were assumed to be entirely airless. Pluto is the only trans-Neptunian object previously confirmed to hold an atmosphere, and Pluto is nearly 5 times larger. What made the discovery even more puzzling was that earlier James Webb Space Telescope observations had found no trace of the volatile ices that would typically be expected on such a surface. If those ices are absent from the surface but gas is present above it, the source must lie beneath, either residual internal heat-driving cryovolcanic activity or a recent impact excavating buried material. Either way, something is happening inside this object that nobody predicted. Astronomer Scott Shepard of the Carnegie Institution for Science noted that the finding demonstrated the Kuiper Belt is not a cold, dead place, but a region harboring many building blocks for complex chemistry. If this one object has a detectable atmosphere, others likely do too, waiting for precisely the right stellar alignment to reveal them. New Horizons finds something that should exist. New Horizons was launched in January 2006, faster at launch than any spacecraft before it. It crossed the Moon's orbit in 9 hours, reached Jupiter in 13 months, and after 9.5 years of continuous flight, arrived at Pluto. After 13 years, it reached Arrokoth. As of 2026, 20 years after launch, it sits roughly 64 astronomical units from the Sun, still traveling at over 14 kilometers per second. A signal from mission control takes more than 8 hours to reach it. A command and its confirmation span an entire working day. As New Horizons pushed beyond 45 astronomical units, where models predicted the belt's population should begin thinning, the onboard dust counter kept detecting impacts. Dust in the outer solar system comes primarily from collisions between Kuiper Belt objects, so dust density is a direct proxy for how much material exists in a given region. Beyond roughly 50 astronomical units, the known population drops off sharply, and dust production should decline in step. Instead, between 45 and 55 astronomical units, readings remained persistently elevated. Something was producing dust in a region where, according to 3 decades of modeling, almost nothing should exist. Data published in early 2024 pointed to 2 possible explanations. Either the main Kuiper Belt extends much farther outward than current models estimate, or a second, previously unknown population of icy bodies exists beyond the classical belt, a separate outer ring producing its own dust. Alan Stern, New Horizons principal investigator, described the finding as potentially the first time any spacecraft had discovered a new population of bodies in the solar system. As of early 2026, New Horizons is in hibernation mode, conserving power as it pushes deeper into the outer belt. It is expected to exit the main Kuiper Belt sometime around 2028 or 2029, with sufficient power to remain operational into the 2040s. No suitable target for a third close flyby has been identified. New Horizons may complete its crossing of the Kuiper Belt without ever seeing another world up close. A solitary traveler threading through an ocean of darkness between islands spaced tens of millions of miles apart. A new census about to begin back on Earth. The next revolution in Kuiper Belt science is already underway. The Vera C. Rubin Observatory in Chile, equipped with the largest digital camera ever built for astronomy, has begun its decade-long legacy survey of space and time. It is expected to discover approximately 35,000 new Kuiper Belt objects, a tenfold increase in the known catalog, allowing astronomers to map the belt's orbital structure with a precision that current surveys cannot approach. Subtle patterns currently buried beneath the noise of incomplete sampling will emerge with statistical clarity for the first time. One of the most consequential tests concerns an unresolved debate that has divided the community for years. Certain distant Kuiper Belt objects on highly eccentric orbits share unusual alignments, clustering in ways difficult to explain by chance. The leading explanation is gravitational shepherding by an unseen massive body orbiting far beyond the main belt. This hypothetical object, sometimes called Planet 9, is estimated to be several times the mass of Earth, orbiting at distances of several hundred astronomical units or more. In September 2025, a survey analysis published in the monthly notices of the Royal Astronomical Society proposed that an unseen planet, at least 25 times more massive than Pluto, might reside within or just beyond the Kuiper Belt itself. Some researchers argue the clustering is a statistical artifact of observational bias. Others maintain the signal is real. Rubin will generate a census comprehensive enough to settle the question in a way no previous survey ever could. The boundary of everything beyond the Kuiper Belt and its scattered outer fringe lies a structure that has never been directly observed. The Oort cloud, hypothesized by Dutch astronomer Jan Oort in 1950, is a theoretical shell of icy bodies surrounding the entire solar system at distances ranging from roughly 2,000 to 100,000 astronomical units. Its existence is inferred entirely from the behavior of long-period comets arriving from random directions with orbital periods stretching into millions of years. They must come from somewhere vast and roughly spherical. The Oort cloud is the name we give to that somewhere. At its outer edge, the Oort cloud extends more than a third of the way to the nearest neighboring star. The solar system, properly defined to include all gravitationally bound material, is not the compact arrangement of planets that fits on a classroom wall. It is a structure measured in light years. At New Horizons' current speed, it will not reach the inner boundary of the Oort cloud for approximately 700 years, or the outer boundary for roughly 30,000. The fastest object humanity has ever launched will spend 7 centuries just approaching the true outer threshold. If you compressed the entire solar system, Oort cloud and all, so that its outer boundary fit inside a football stadium, the entire planetary system from Mercury to Neptune would occupy a volume no larger than a tennis ball at the center. Everything humanity has ever visited, every world ever photographed, every spacecraft ever launched, all of it fits inside an object you could hold in your hand. That is what the Kuiper Belt introduces. Not a single discovery, not a single startling fact, but a complete structural reckoning with what the solar system actually is. The warm, bright zone where 8 planets orbit, the zone that civilizations have mapped and named for thousands of years, is a small sheltered clearing at the center of something incomprehensibly larger. The Kuiper Belt is where that clearing ends, where the sun stops feeling like a presence and starts looking like a star, where temperatures have not risen above -200 degrees in 4.5 billion years, and objects drift unchanged through darkness so complete that the concept of a sky, in any sense a human being would recognize, ceases to apply, and yet it is ours. It belongs to the same star that rises over your horizon every morning. It formed from the same cloud of gas and dust that built the ground beneath your feet. The same gravity that holds you to Earth reaches outward across billions of miles and holds every Kuiper Belt object in its slow, cold orbit. The solar system does not end at Neptune. It barely ends at all. What lies beyond Neptune is not the distant edge of something familiar. It is the beginning of something we are only now, for the first time in all of human history, beginning to see clearly. And what we're finding out there, active geology on frozen worlds, ancient chemistry preserved intact since before the Earth existed, shapes that record the very birth of planets, atmospheric detections where no atmosphere should be, dust signals pointing to populations nobody predicted, suggests the surprises are nowhere near finished. The picture is getting bigger, and it is getting stranger, and we are just getting started. If this video changed how you think about the solar system, don't forget to leave a like and subscribe. Every bit of support helps the channel grow.